Good morning, everyone. Today I figured I'd talk through a little bit about concentration equations and how to do them. So let's get straight into it. No, did not want to do that. Let's actually use buttons. Alright, so first slide here is talking about the concentration of a solution. So most of you have heard of concentration before, you know what it means. So essentially what it is the number of particles that are dissolved in a particular solvent of a particular size. So you can see down here we've got three varying concentrations and they match up with kind of some of the concentrations up here in terms of intensity. So the first one, you've only got a few small particles in a big thing of water, and then as you go on and get more concentrated, you've got more little solute particles being dissolved in that water. So it's more concentrated, there's more particles there. So the way that we actually calculate that is the way we calculate molarity. So the moles of the solute, which is N, you should already know that, divided by the volume of the solution, which is in liters. So that becomes moles per liter, which is our concentration. Yeah, that's just what concentration units is made out of. So down the bottom here, I have two examples of really quite good triangles that are really good ways to kind of understand and remember these sorts of formulas. So it is a triangle. At the top you have N, which is number of moles. Then you've got concentration, which is moles per liter or molarity. And you've got volume, which is in liters over here. So if you can remember NCV, then the way that you use this is if it is on the top, so N, it's going to be divided by C or divided by V to get the other one. And if it's on the bottom, so if you're trying to find number of moles, then it's concentration multiplied by volume. If you're trying to find the concentration, it's number of moles divided by volume. And if you're trying to find the volume, it's number of moles divided by concentration. So it's a very easy way, I guess, to rearrange the equation and to help you remember it. Hopefully that makes sense. Essentially what you do is you cover the one that you are trying to find, and then you do whatever the other one is, so times or divide. I hope that makes sense. And I just really liked this picture. All right, next slide. Number of moles in a solution. So sometimes you won't have the number of moles, you might be given the mass, and you know the atomic mass, so then you can work out the number of moles to then be able to find out the concentration. So again, I have two triangles here that probably will help. So moles here is mass divided by molecular mass, which is represented by an M with a little tiny r next to it. Don't ask me why it's represented by that, but we're going to go with it. In this triangle here, we've got mass at the top, then moles and molecular mass. And this is kind of what I was trying to say before. If you cover up the mass at the top, you then use moles and molar mass and multiply them together, and that will give you what the mass is. If you're trying to find moles, then you do mass divided by molecular mass, and you're not ever probably going to try and find that, but if you were going to try and find that, it would be mass divided by moles. So there's two more triangles here. What you should be doing with these two slides is you should be going through and copying down the formula, copy down the one of the two triangles, and hopefully that will be helpful to you. Hopefully. So both of those, oh, stop doing that. So for both of those, you should be able to easily do that. And now we get into some example problems. So this is probably the part that's going to be maybe a little bit confusing, but it is very important that you understand how to do these kinds of equations. So we have our question. 12.6 grams of sodium chloride are dissolved in water, making 344 mils of solution. Calculate the molar concentration. So the first thing we need to do is we need to work out, well, what do we know, what do we not know? So if we come up here, we know that we have 12.6 grams. Highlight this. No, of course not. We've got 12.6 grams and it is in 344 mils of solution. So we know the volume, which I've then put down here, and that is in milliliters. So then we need to make it into liters. So this right here, 0.344, is how many liters of solution we have. So we worked that out. That's fine. We know the mass. So I've come and put the mass down here. That's 12.6 grams. We can also very easily work out the molecular mass. So if you've forgotten how to do that, the molecular mass is just from the periodic table for all of the elements in the solution. So in this case, sodium is 22.99, chlorine is 35.45. So you add those together and you end up with 58.44 grams per mole. So that is our molecular mass. So we have mass, we have molecular mass. Now we can use that information to find out the number of moles. So we go to our little triangle, we're trying to find moles. So we're going to do mass divided by molecular mass, which is down here. Mass divided by molecular mass. And that gives us the number of moles of that number of grams of that particular solution. Hopefully that makes sense. Once we've worked that out, that number is then going to be added into our little section up here, which then gives us number of moles and volume, so we can now work out concentration using our equation, which is here. Concentration equals number of moles divided by volume. So once we've got that, we can input all of our information in, and we have our answer of 0.627 moles. Hopefully that process makes a little bit of sense. Let's go, I suggest copying this down, but we're going to go onto the next example. So the next example, how many moles of sodium chloride are contained in 250 mils of solution with a concentration of 1.25 molar? So this one, we're trying to find number of moles, which is N, and we have both of the other variables for the concentration equation. So it is fairly easy. All we need to do is write down our other variables. Again, putting our volume into liters, it is a good practice to get behind. So 0.25 liters. And then just input it into the equation. So 1.25 multiplied by 0.25, that gives us the number of moles, which is 0.313. Again, hopefully that makes sense, and hopefully you got all of your understanding of this is fine. If not, don't be afraid to ask the questions, but make sure you've got this copied down, and we'll move on to the next one. Alright, this is the last example practice problem that we've got for concentration. So what volume of solution will contain 15 grams of sodium chloride if the solution concentration is 0.75 molar? So we have 15 grams, firstly, and then the next thing we have is our concentration. So we've written down our 15 grams over here, and I've written down the concentration over here. And I typically tend to do question marks for things that I don't know, so I can kind of work out what I need to know. So in this type of example, the first thing I would do is I would write down anything that I have. So these two things up the top here, that is what I do. And I also put down what do I need to know and how do I find that. So I need to know the volume, and the only way I can find the volume is with this concentration equation. So I write down the things that I know and don't know from that, and then I work my way backwards to then find out the things that I should know but don't know yet, if that makes any sense. So I actually start by writing this information down, except for the stuff in red. And then when I have multiple question marks, I go, okay, can I find out one of these with the other information that I've got? Yes. Okay, let's go write that stuff down. I hope that makes sense. So again, writing the stuff down is sodium chloride again. So it's got the same molecular mass. We've got a different mass though this time. So when we go through and calculate all of this, we end up with 0.26 moles. That number is then put up here in our concentration equation information, and then we use our triangle to work out how do we calculate volume. So volume is just number of moles divided by concentration, so we just input all that information in, and it tells us that the volume is going to be 0.35 liters or 350 milliliters. So that is another example of a different variation of the equation. I hope that all of this is making sense. So again, copy this down, make sure you understand it, and let's move on. The last thing about concentration we are going to talk about is parts per million or parts per billion, which is ppm or ppb. This is another form of concentration unit that you will find. It is fairly common when you are using very, very, very small numbers. So particularly maybe the mass or the volume, it needs to be very, very small for it to work. So in here I've got the example. So parts per million is when you do the normal mass concentration solution, and then you have to multiply it by 10 to the power of 6 to get a number that is very easy to understand, or that you can see properly. Parts per billion is 10 to the power of 9, same concentration as before. So it's concentration, number of moles, and volume, pretty much. Technically this is mass divided by volume, similar things. So essentially here, very important, you must have the same mass and volume units. So if you are using grams, you should be using milliliters. If you're using kilograms, you should be using liters. So this is when you are combining these sorts of things. So depending on what your particular problem is, this is going to probably be very helpful. So we've got an example problem of this for ppm, which is an Olympic-sized swimming pool contains 2.5 million liters of water. If 1 teaspoon of salt is dissolved in the pool, what is the concentration in ppm? So 1 teaspoon of salt is 6.75 grams, and we have 2.5 million liters of water. So again, they must match. So we either need to make the grams into kilograms, or we need to make the 2.5 million liters into milliliters. So the way that they've done that in this sample problem is to turn it into milliliters. So the 6.5 grams stays the same, and then we have the 2.5 times 10 to the 6 liters, which is 1,000 milliliters to 1 liter. So we're going to be multiplying that by 1,000 pretty much to get the answer to that, and then that's being multiplied by 10 to the 6 to make it parts per million. So when you go through and actually calculate that, you end up with 0.0027 parts per million. So that means per every million liters, there is 0.0027 grams. I hope that makes sense. Oh, sorry, 0.0027 kilograms. So that is essentially how it works. So it's very easy. You just put the grams there, the solution number, so the mass at the top, the volume at the bottom, then you multiply it by this number here, depending on if you're making parts per million or parts per billion, and it comes up as a easily recognizable number. If we didn't do this part, then our number would be like 0.00000000027 or something ridiculous like that, and that's not easy to use in other calculations, and it's not easy to see and understand. I'm hoping all of this makes sense to you. What you are going to be doing now, after you've copied this down, that is the end of the lesson. There will be a concentration equations practice worksheet for the next 2 lessons, both of which will have walkthrough videos where I sit down and I go through how to actually calculate these things, and I just go through all of the problems and do the answers for you. So don't go and look at that video until you've attempted to do the questions, but when you get stuck, that's what it's there for. So hopefully this made sense and it didn't confuse you more, and I shall see you for the next lesson. Bye bye.